Welcome to Study Loop.
So in this problem, we are given a buffer of benzoic acid and sodium benzoate in 1 liter of water, which has a pH of 4.55. And the freezing point is minus 2 degrees C. The density of the solution is 1.01 gram per ml. So we have to calculate the concentration of benzoic acid and sodium benzoate. So first we have to do is to calculate the ratio of the concentration of sodium benzoate and benzoic acid using the Henderson-Hasselbalch equation, which is as follows. The pH is equal to pKa plus log of base concentration over acid concentration. So first we have to find the value of this ratio here. So if we just we know the pH value, which is 4.55, and the pKa value for the benzoic acid is 4.19 or 4.187. So you can write the pH we need is 4.55. pKa for the benzoic acid is 4.187 plus log of base over acid. So if we just solve this equation, we will find the ratio of the base concentration to acid concentration as 2.306. So this is the ratio of the base concentration to acid concentration. Now we have to use the freezing point depression to find out the molality of the solution. So as you know that the depression in the freezing point is given by del Tf is equal to m times Kf. So here del Tf is the depression in freezing point, m is the molality of the solution, and Kf is the freezing point constant, which has a value of 1.86 degrees C per m. So from here we can find the molality of the solution just by putting the del Tf over Kf, and as we have seen, the freezing point depression value is 2 degrees C. And the Kf value we have here is 1.86 degrees C per m. So from here we will have a value of 1.075 m, which is the molality of the solution. And then we have to find out how many mole of acid and base we have here. We will use the value of the molality to find out that. So the sodium benzoate will be dissociated as NaC7H5O2 sodium benzoate, and this will be dissociated as Na plus aqueous plus C7H5O2 minus. So that means that 1 moles of this sodium benzoate is giving um, in total 2 moles of the solute. That means 1 mole sodium and 1 mole benzoate ion. And that means the total moles of solute, if we calculate that, it will be like 1 mole benz 1 mole of benzoic acid plus 2 mole of sodium benzoate. So this is equal to the molality of the solution we just calculated. So that means that 1 mole of acid plus 2 mole of base we have here, and that is equal to the molality of the solution we calculated here. And then we have to convert it to all the number of moles of acid. So we can do this by and then converting this sodium benzoate to the benzoic acid by just multiplying the mole ratio we just calculated. It will be 2 times 2.306 mole of the acid or the benzoic acid, HC7H5O2. So our this value is coming from here, which is our base to acid concentration ratio. So you're multiplying this by 2 to convert the base to acid. This will be equal to 1.075, and then that means in total we have 5.612 mole acid HC7H5O2 equal to 1.075, and from here we can find mole of HC7 H5O2, the benzoic acid. I just simply 1.075 over the 5.612, and it will give us 0.192. So this is the mole of the benzoic acid, and then here we can find the mole of sodium benzoate by just multiplying this with the mole ratio, or the ratio of the concentration of base and acid. It will be 0.192 times the ratio, which is 2.306. It will give us a value of 0.44. So this is the mole of sodium benzoate. Now we have to find the mass of the acid and base. That means the molar mass of our base here, which is sodium benzoate, is 144.11 gram per ml, gram per mole. And then that means the mass of base is molar mass times mole times the number of moles. You just calculate as 0.44 mole, and it will give us a value of 63.41 gram of base. So this is the mass of the base, and then similarly we can calculate the mass of acid, which is the benzoic acid, by simply multiplying its um, molar mass, which is 122.1 gram, times 0.192 mole, as this is the number of mole of acid which is calculated. So this will give us the mass of the acid, which is 23.44 gram. So now we have to calculate the total mass of the solution. If we just sum up the acid mass, the base mass, and the mass of water, which will be 1000 gram water, we have mass of acid as 23.44 gram, plus the mass of base 63.41 gram, plus the mass of water, which is 1000 gram, and the total mass will be equal to 1086.85 gram. So this is the total mass of the solution. Now we have to calculate the volume of the solution. So we are given that the density of the solution is 1.01 gram per ml, and now we know as you know that the density is equal to mass by volume. That means volume of the solution is mass by density. So mass we have calculated as 1086.85 prime gram over the density, and this will give us the volume in 0.01 0.001076 milliliter, or if we convert it to liter, we'll have 1.076 liter. So this is the volume of the solution. Now we can calculate the concentration of the solution. So the concentration of the acid or the benzoic acid will be simply the number of moles of acid, which we calculated 0.192 mole, over the total volume we just calculated 1.076. It will give us the concentration of the benzoic acid, which is 0.18 molar, and our concentration of the base or sodium benzoate will be equal to the number of moles of base we calculated 0.44 mole over that volume 1.076 liter. This will give us the concentration of the base, which is 0.41 molar. So this is the concentration of the acid, which is H C7H5O2 or the benzoic acid, and this is for the base sodium benzoate NaC7H5O2. So this is the required concentration of the benzoic acid, and this is for sodium benzoate, um, that is buffered at a pH of 4.55 and has a freezing point of -2 degrees C.